Hello students, welcome to our session, and today we are going to learn about chapter number 14. The name of this chapter is light. Light is very important in our life. Without light we cannot see anything at night, because at day it is possible because of the sign of the sun. We can see anything around us because of light of the sun. But at night, what we do, all we do not have light. You all know the importance of light in our lives. You cannot see anything without light. If you enter a dark room or visit a park at night, you cannot see anything without a source of light. In class 6, we have already learnt that sources of light are classified as luminous and non-luminous bodies. In our previous class, in our previous standard, we have almost learned about this topic about luminous and non-luminous objects, sources of light. Objects like the sun, stars, etc., that emit light are called luminous bodies. Most objects like table, chair, plants, human body, etc., do not emit light and are called non-luminous bodies. These are the example of both sources, luminous body and non-luminous body. Light travels in a straight line. Always you can observe this kind of thing. Light always travel in a straight line. Light is a form of energy. This is a one type of form of energy. It travels in a straight line. Always light travels in a straight line. There are a number of examples in our daily life. We have lots of examples in our daily life which suggests the straight line motion of light. This type of example always shows the light always travel in a straight line. For example, the formation of shadow suggests that light will travel in a straight line. Similarly, when a beam of light enters a dark room through a gap in the curtains, we can see the light traveling in a straight line. Figure 14.2 show this sunlight beam in room. You can also observe this kind of thing at your home. When you see this, you can observe the light always sunlight beam in room come in straight line. The property of light traveling in a straight line is called rectilinear propagation of light. And for this, let us perform activities 14.1 and 14.2 to understand the properties which light has. So before we talk about these activities, try to keep with you a textbook, because textbook will help you very much. So when you see this video, keep textbook with you. Now here we have activity 14.1 to observe the path of light. Take a chart paper and roll it into a pipe. Look at a lighted candle through it as shown in a part A. You can see here in part A the boy see through a pipe. Candle he see the candle using a pipe. Take care not to touch the chart paper with the flame. Now bend the pipe from the middle and repeat the activity as shown in part B. In B, you can see there a boy bent this pipe. Why are you not able to see the lighted candle through the bent pipe? You cannot see in part B. Light travels in a straight line and does not bend with the pipe. So using this activity, you can see the light path, how we can see when we can see only the light flame when we using a straight pipe. When we bend this pipe, we cannot see the flame which we have. Then we have another activity, activity 14.2. You can see here, to prove that light travels in a straight line. This activity prove light travels in a straight line. You can see here we have also rectilinear propagation of light, and for this we have also figure available. You can see here in figure candle, then some types of wallpaper you can see, then plastic, they are made by plastic. Take 3 cardboards of similar size and make a hole in the center of each. Make sure that the size and position of the hole and in the same in each cardboard. They make the hole through these 3 cardboards in same. Now put the 3 cardboards in vertical position. You can see here they put them in vertical position with the help of a brick or clay in such a way that the holes in the 3 cardboards are in a straight line. They put them in a straight line. Place a lighted candle in front of the cardboards as shown in the figure given alongside. Look through the hole of the last cardboard. Are you able to see the flame of the lighted candle? What happens when you displace one of the cardboards? When we displace one of the cardboards, what happened there? The flame can be seen clearly through the holes in the first case. When we put them in a straight line, we can see them properly. But when we displace them, we cannot see. On displacing one of the cardboards, no flame can be seen as light cannot bend. As in our 14.1, we cannot see when we bend our pipe. Like this, we cannot also see here when we displace the straight lines of the cardboards. Light travels in a straight line. No flame can be seen when the holes of the 3 cardboards are not in a straight line, because light cannot bend. That means light always travels in a straight line. These both 2 activities prove that. You can see here this activity with the figure available in our textbook, and this activities proves always light travels in straight line. So we can also see a light using a straight line formula. Now our another topic, reflection of light. Reflection of light. You have already familiar with this word reflection, because revolution and rotation of earth, the reflection of moon has not its own light. We can see light on the moon because of the reflection light of the sun. We all know about this reflection of light, how light reflect using 2 different things. Now you know that light travels in a straight line. Now you have all know light always travels in straight line and does not bend or change its path. But what happens when light falls on a shiny or polished surface? The rays of the light change their direction or path when they fall on a shining steel plate or spoon or mirror. The surface of water can also act as a mirror and change the path of light. See the reflection of Taj Mahal in water in figure 14.3. You can see here the reflection of light. Because of this, you can see the same picture of Taj Mahal in water also available. When light falls on an object, when lights fall on an object, some of it is absorbed and the rest is bounced back. Some it is absorbed by this object and some rest is bounced back. Reflection is the bouncing back of light from the surface of an object. Also a polished block of wood reflects more light than an unpolished one. Some light will absorb and some not. In other words, light is reflected better by smooth and polished surface. All type of objects reflect the light. Some light will be using by this type of object and some will not. That means, in other words, light is reflected better by smooth and polished surfaces. Reflection of light depends upon the nature of object through which it passes. Reflection is depend upon the objects through it pass. For example, the steel surface of water and oil, polished furniture, shiny metal surfaces, and polished surfaces, etc., are smooth and can turn back the ray of light in the same medium, thus acting as a mirror. That means these kinds of things reflects light better because they are polished and smooth. Now we have also activity 14.3. You can see here activity 14.3, and this activity tell us to prove that smooth and shiny surfaces reflect light better compared to other objects. This activity prove us that place objects like a mirror, and for this activity they use things like a mirror, a shiny steel plate, a plastic plate, or a sheet of paper near skin, which can be wall or paper sheet. You can see here in our figure also mirror, cover up sheet, paper. Shine a beam of light through a torch on these objects in such a way that reflected light falls on the screen as shown in the figures given alongside. You can see here mirror, cover up steel plate and paper, because they using different kinds of things and prove how smooth and shiny surface reflected light better compared to other. So they use mirror, cover up steel plate which we have in our kitchen also available, and a paper of our notebook, etc. You will observe that in case of the mirror, a bright patch of light is seen on the screen. Similarly, in case of the steel plate, a patch of light is visible on the screen, but when you use a paper sheet, no patch of light can be seen on the screen. This activity you can also do at your home because this is very easy for doing and you can understand. Shiny and polished objects like steel, plate, mirror, polished wood piece, etc. reflected more light and form a brighter page on the screen. Rough and dull surfaces, on the other hand, reflect less light and do not make a patch on the screen. That means this activity proves that shiny and soft objects reflect light better compared to other objects. Now we talk about our next page. Here we have again activity 14.4, to observe the reflection of light through a plane mirror. For this they take a torch and cover its glass portion with a chart paper having three slides as shown in the figure given alongside. You can see here figure available. Reflection of light through plane mirror. Types of mirror. Plane mirror in them. Put a plane mirror vertically on another chart paper fixed on a wooden board. Now switch on the torch and direct the beam of light on the mirror through the slits at an angle. Put the torch in such a way that its reflected light is seen on the chart paper. You can do this activity in a dark room also to have better results. What do you observe after this activity? Is there any change in the direction of light rays which falls on the surface of the mirror? Move the torch to either sides and see what happened. Now change the direction of torch and observe what happened there. Do you find any change in the direction of reflected light? Look into the mirror along the direction of the reflected light. Do you see the slits in the mirror? The beam of light gets reflected from the surface of plane mirror. This activity proved that, as seen in activity 14.4, the beam of light that hits the surface of the mirror gets reflected. The path taken by the ray of light is shown in the ray diagram. You can see here the ray diagram. The ray of light that falls on the surface of the plane mirror is called incident ray, and the one that is reflected off the surface of mirror is called reflected ray. If you look carefully, you will find that there is a relationship between the angle and at which the incident ray hits the mirror and the angle at which it is reflected off. There is a relation between them. The incident ray and the reflected ray both ray from equal angles with the plane of the mirror, or we can say that angle or incidence is equal to the angle of reflection. Before we proceed further, let us first understand more about images and reflecting surfaces. We have also about them in detail in our textbook. We will talk about them in our next session. First, you can see here in figure 14.4, ray diagram of reflection through plane mirror. They use their plane mirror. You can see here both rays are there, incident ray and reflected ray. You can see here they use incident ray and reflected ray. Then we have angle here we have angle. You have also familiar with angle because you have learned in your maths. So this prove both have equal measure there. They prove us. You can see here also using this figure. So students, our this session is finished here. We will talk about our other topics in our next session. Till then, take care.